everyone, welcome back. In this particular video, we will be discussing the problem string permutation. What we are given is a string. What we need to do is we need to rearrange the characters of the string using a given permutation. Permutation is just nothing but a rearrangement of characters. Permutation will be in the form of an integer array with a size same as that of string, in which each integer specifies the new position of the character currently present at that particular place. Basically, what we will say is, let's say the input string having A, B, C, D. If input string is having A, B, C, D, there are 4 characters in this input string. What will be the length of output string? Length of output string will also be 4 characters. But what will be the length of permutation array? That will also be 4. The example taken is having values 2, 4, 3, 1. So what are these values specifying? Permutation array specifying that each integer will have the new position of the corresponding character. That is, for the character A, the new position in the output will be the second character. And as you can see, it is starting from 1 based indexing, not 0. So it will be the second character in output. That is here. If you just replace 4 dashes, second dash will be replaced by A. B will be having the fourth index, or you can say the fourth character. That is the last character actually. C will still be the third character and D will become the first character. So output will become DACB, as you can see, and that is what you are expected to return. So given an input string having some characters, most probably you can assume distinct characters will be there. Even if there are same characters, then the algorithm will not change. And second thing is a permutation array. But permutation array is important. Why? Because it should have all the values to be unique. There should be all the numbers from 1 to n. If it is invalid input array, then you will not be able to form the output string. Let's say if both of these numbers were 4, 4 only, then how can you place both A and B at the fourth character, at the fourth index? It will not be possible. So you can assume that the input will be a valid input, that is string will have same number of characters as the permutation array, and permutation array will be having equal number of characters. Uh, Also, the arrangement from 1 to n will be there. No characters will be repeating. But the point is how we can solve this problem. First of all, since we need a new output string, let's create a new output string of how much length? Of the length same as the input string. So let's take a bigger example this time. Let's take a string is A, B, C, D, E, F, G. So obviously the permutation array will be of the same length. Let's just give indices. We know that indexing always starts from 0. So let's assign these characters the indices. And let's also have the permutation array. So permutation array which I'm having is, let's say 7 here, let's say 2 here, let's say 5 here, let's say 4 here, let's say 1 here, maybe let's say 6 here, and let's say finally which number is remaining. I think 3 is remaining. So let's say 3 is here. So from 1, 2, 3, 4, 5, 6, 7, every character is present. So this is the permutation array given to you. A array of 7 elements only, because n is 7. So output will also be of 7 characters. If you are creating an output array of characters, or you can say output string of characters, you can assume each character to be a null character initially, or you can say each character to be empty character initially. So there will be 7 characters in the output. So let me just draw 7 dashes, 1, 2, 3, 4, 5, 6, 7. And of course, the indices for output will also start from 0. For permutation array, the indexing will also start from 0. Now let's start with the logic. What we want? We want a character to be present at the 7th index, but 1 based indexing. How will you convert a 1 based indexing into 0 based indexing? How will you convert numbers from 1 to 7 into 0 to 6? You can just subtract 1 from them. That is what you will say is, don't place the character A at the 7th index. Rather place it at the 6th index. That is 7 minus 1th index, which will be the last character actually. Place the character B at 2 minus 1. That is first index. That is at the same index itself. Place the character C at the 5th index. This is already done, but not at 5th actually. It will be C as 5 minus 1. That is 4th index. That is here. Place the character D at the 4 minus 1, 3rd index, which is here itself. Place the character E at 1 minus 1, which is actually the 0th index. That is very first character. F character should be placed at 6th index. So we will place at actually 6 minus 1 because we wanted to use 0 based indexing. So we will place F here itself. And finally, G will be placed at 6, at the not 6, but rather 3 minus 1. That is the value, not the index. 3 minus 1 index, which is the second index. So we will place G here. So finally, we are able to form this output string. If let's say your language does not support to create an output string which can be modified, that is, if your language have an inbuilt string to be immutable, then what you can do is you can first create a character array and then convert that character array into a corresponding string. However, if the language supports to modify a string, that is, if by default the strings are mutable in your language, then you can directly go ahead and modify the same string will not work, but you can just create a copy of the string and then work on that string. Why same string will not work is if you are saying A, we want to update it at the 7 minus 1 sixth index. And if you are just using the same string itself, if your language allows you to modify it, you will update the sixth index of the same character. But after the traversal, when you will reach at the sixth index, you don't know what is the original value. Where is D? You don't have it now. That's why modifying the same string itself, you will not be able to rearrange the characters based on the permutation. You have to create a new string only. So what will be the overall time complexity just by seeing the approach? Since we are running a loop over all the n characters one by one and just checking what is the index for them to be placed in the output, and placing them is a constant operation. So since we are doing constant operations for n times, overall time complexity be order of n, that is linear. But what about space? Now, if you will say that there are usually three kinds of space complexities which we analyze. One space is taken by input data structure. Second type of space is taken by the output data structure. And the third space is actually the extra space which you take in order to solve the problem. So first thing, if we talk about input data structure, then it will be your input string and the permutation array, both of n sizes each. That is order of n input data structures space. When it comes about the output data structure, you will be having this string having n characters. And since you have to create a new string, we will say that output will also be order of n, that is of n characters output string. But when it comes to extra data structure, now it comes whether you are using a language which allows you to create mutable strings, or whether it does not allow your default strings to be mutable. That is, default strings are immutable. So if it is mutable strings by default, then you will not actually require any extra space because you can just use these three strings or these three arrays. That is, one is the input string, one is the output string, and one is the permutation array. You won't require anything extra apart from these three things, input, output. But when it is a language where the strings are immutable by default, in that scenario, what you will require is a first character array, and then you will convert that character array into the corresponding string. So since you will require this character array, which is not an input, not an output, it will be linear extra space. So based on whether you are required to create a character array or whether you can directly do it on strings itself, the extra space complexity will change. Usually you can say in languages like C++, in languages like JavaScript, you will be requiring constant extra space. However, in languages like Python or Java, where your by default strings are immutable, you will actually be requiring a character array and then converting that into a string. So there will be linear extra space. Now that we have discussed our approach, and actually it is the most optimized solution, you cannot do better than this any fashion. You cannot improve the time complexity. You cannot also improve the space complexity. We are done with the second milestone. Let's now write the instruction manual in the third milestone. What we will do in this function is we will say, first of all, create a character array or create a output string, whatever your language allows. Let's say we are saying character array of, however, in the bracket, I am just writing a string of n size. You can assume every character will be initially null character or empty character, something like that. We don't care what is the initialization. We only want n characters array or n characters string for the output. Now what we are going to do is linearly iterate over all the characters. That is, run a for loop over indices. Since we have to run loop over characters, we have to know their indices. Where are they? 0, 1, 2, and so on. So we have to run the loop over indices 0 till n minus 1, where n is the number of characters or the string's length or the array's length. While running the loop, how will we get the character? It will be from the strings character at the given index. So character will be, you can store character, store ch character as what? As the character at the strings index, at strings I index. The I is a variable which you are using to run the loop. But what about the index where you have to store in the output? So let's just store the index where you have to store in the output as IDX. And that IDX index will be the permutations value present at the current index. That is permutations of I. But since permutations array is having one based indexing values, you need zero based indexing values. You will have to subtract one from it. That is convert one base into zero base. So you know the character which needs to be stored. You know where to store it. Now the only thing is just update the character at that index. So update the character at the index itself in output string as the current character, as ch character. That is whatever character you got, whatever index you got, just map them. If character was a, index was 7 minus 1 6, just go to sixth index and map the character a or store the character a and so on. So finally, after this entire loop, what you will be able to do is form the output string. So you just have to return it, return the output string. Obviously, you have to return it in a string format because return type usually will be a string, not an array. So that was the instruction manual, which will be taking linear time and linear space. That is both linear time complexities and space complexities will be there. Now we will be writing code in Java programming language specifically. So let's just get started. First of all, since in Java, the strings are immutable, you can't modify characters in a string easily. That is in constant time. That's why what we will require is a character array for output. Then we will convert that character array into the corresponding string. So let's create an array of characters. Let's name it resultant. You can name it anything actually, the output string. And it will be having how many characters? N characters only, same size of the input because input string is just rearranged. No change in the number of characters, no insertions, no deletions. Now, in order to map the characters in output, we have to run a loop over input characters. That is, go to each and every index, starting from 0, going till n minus 1, and doing index plus plus. This is the input string index. But we want the character at that index. And how will we get the character at that index? That will be strings character at. This is a function which we use in Java to get any character from a string at a given index I. But we also want where should that character be stored in the output. So for that, we are creating a variable idx. You can name it better also. You can name this I variable as input index. You can name this idx variable as output index, but it is up to you how you want to name those variables. What we want to store is where that character should get stored in the output. That will come as the permutations of I minus 1. That is the 1 based indexing minus 1 will make it 0 based indexing. So we know the character, we know the index where to store it in the output. So let's just now store it. That is in the output, since it is an array, we will use square bracket syntax, not char at function. So we will say in the output at the given index, we will store the character. That is character was A, we have to store it at 7 minus 1, 6 index. So go to 6 index and store the character as A in the output string. Finally, after this entire loop, we will be able to form the output in the form of an array, in a character array. But we have to convert that character array into a string because return type is a string. So in order to convert a array into a string, we can use the constructor of string. That is what we will do is return a new string, and inside the parenthesis of that constructor, we will pass the array. So this will do what? This will convert the character array into the corresponding string. So what will be the overall time and the overall space solution of this solution? It will be, since we are running a linear loop over the input string of n characters and doing some constant operations, the overall time complexity will be order of n or linear. What about space? Since we are creating a character array which is neither in the input nor in the output, we are taking extra space of order of n again, that is linear only. So both time as well as space is linear. Now let's just run the code to confirm whether it is working or not for all the scenarios. First, we are running it to just confirm it for the sample test case. However, there is some small issue with the symbols. So the array name is not permutations, rather it is permutation. It is just a slight change in the variable name. That is, the array name is not permutations, rather only permutation. Also, one more thing is the output string name is not output itself, it is resultant, RES. Now, hopefully, it should work. Let's see if it is now working by running the code. So that's why I recommend everyone to first run your code and check if there are any compilation errors, because while hitting the run button, it will first compile your Java code and then run it. So it will show you all the compilation errors, as well as it will show you if there is any logical error while running the code for the sample test case. If sample test case is showing the actual output equal to expected output, then you can go ahead and submit it to confirm whether it will work for all the test cases or not. So let's just wait for it. And it is working for all the sample and edge scenarios as well. What might be edge scenarios? It might be the input string is almost same as output. It might be input string as just the reverse of output. So in every kind of scenario, it will work, provided that the permutation array is a valid array. That is, it is having unique letters or unique digits from 1 to n. So that was all about the problem string permutation. We will meet in a new video with a new problem. Till then, bye bye. Take care.